For you left, we're finding the critical values, the TC, the critical values. Now, we talked about your T. It works, it builds a normal curve, but you don't have to subtract it from 100. You don't have to divide it by 2. You just have to follow your chart where it gives you confidence level. Follow your chart, in this case, to 0.90. And coming down the left-hand side is degrees of freedom. Degrees of freedom is 1 minus the n. N minus 1. 1 from n. So you're going to find 9, 90, and you're going to come across and find your TC. Okay, now, if you do this on your calculator, just like you did inverse norm, you can do inverse T. It's really nice on your calculator. Go to VARS, second VARS, and go right underneath it. Right underneath inverse norm, it says inverse INVT. It says inverse T as well. So for those of you that like the calculator, I happen to like the table on this one. I think it's just quicker because it says it across the top, it says it down the bottom, and you pretty much have to enter that same exact information into your calculator. So, oh, thank you. Yeah. So it's kind of almost the same amount of work to get there in both places. But if you look at the VARS, as soon as this comes up, I'll do it. It's second VARS. It's right under inverse norm. It's inverse T. Well, I have to enter mine. So I have to enter 90. 90. You're just going to enter your confidence interval, and then you're going to enter your degrees of freedom. If you're on the old one, you have to enter it like this.
Is it on the old one?
It should be. It's not on yours?
It says below it says TPDF.
Oh, then you don't have it on the 83s. Yeah. The 84s have it, but not. Is this the right answer?
No.
Oh, that's
Yeah.
1.833.
1.833, then I must have put something. What does yours say?
It doesn't work. But if you put it in, like, I put it in right when I got it.
It should run area 90.
It's just a different one.
Yeah, I got that too.
Yeah. What if you put in 10? Does it?
No, because it gives you degrees of freedom.
That's weird.
Yeah.
Maybe we're all wrong.
Then we're gonna have to cut a class short today.
Yeah.
Figure out.
This is completely destroyed class.
We can't learn it.
Yeah, I got it, guys.
This math.
All right, so let's hold off on the Can I have everybody's attention here at the same time? If there's any more talking, you're just going to do individual work. Because this is ridiculous in here. You have 15 minutes when class starts to get this out of your system. Okay. Well, the calculator must not be working well, or I don't know how to put it in. So let's do that tomorrow. I'll figure that out later. I put it in yesterday and it worked, so I guess I'll figure that out tomorrow. What if you put it in an area of 5? Let me just see something. So we'll make you do it tomorrow.
You just hit 4.
Oh, I hit the wrong one.
You hit 4. So the second variable hit 4.
She didn't pick the wrong one.
Yeah.
We should do that all over again.
Yeah, I know. This calculator has like a delay. Let me see if this works.
Right?
Yeah.
That's it.
Okay. What you're going to have to do, and it's the same as you did for the Z-score, you're going to have to take the difference, divide it in half, and do a T based on, if it's 90%, 1 minus from 100 would be 10, divided by 2 would be 0.05. That's why I don't use the calculator, because it's more work in the calculator than it is off the chart. Your chart's nice, because it's got confidence on the top, degrees of freedom on the bottom. So I think for that area, you're going to have to put in 0.05 versus the 0.90, the once area, not confidence interval. That's the problem. So if you want to use it, I mean, it's fine. You're going to have to still do the 100 minus that, divided by 2. I've used the table. I think it's a lot easier. Okay, any questions with any of these? What's that? If you just use your table. Okay. 2 and 3 are backwards.
Like,
So if you use your table, your degrees of freedom down the side tell you like how to work that out. But make sure you don't use the N.
I don't know.
Make sure you guys are using degrees of freedom.
No, I got,
Yeah.
1 second.
So did I.
For what number? Because you've got a symmetric curve. So you've got a negative side and you got a positive side. It works the same way as your z-score. Okay? Alright, so today we're going to put together all your probabilities with this and see what that looks like. Make an interval ourselves. We said it's going to work the exact same way. You're going to identify the sample size. You're going to identify the sample mean and the sample standard deviation. Now, most of the time, you will get the sample standard deviation, or you can find it from your L1 if you have to do it yourself, because the degrees of freedom, like, kind of make this a little bit closer in here. It gives you a little bit more precise. It will make your confidence interval be slightly wider by doing this. So it kind of takes up the slack of your sample a little bit. Usually for this one, we don't know our population standard deviation, so we have to use our sample. Basically the same setup, your margin of error, same way, only there's your TC, and there's your sample standard deviation, which you can either find or they'll sometimes give it to you. And we do the endpoints the same way. Remember when we ask for an interval, I want to and from and to. I want the whole thing set up. Okay, so let's do example 6, example 2. It says you randomly, it's on page 297. You randomly select 16 restaurants. There's your N. And you measure the temperature of the coffee sold at each. You have a sample mean. There's your sample mean. There's your sample standard deviation. First thing, guys, pull out your information. These are the pieces that you need. Here they have decimal points, but because they're 0, we don't have to put them in. And you want a 95% confidence interval. Okay? You're going to assume the temperatures are normally distributed. Because our sample is less than 30, they have to tell you that your chart is normally distributed, because we're on the small side here. Now, we're going to create a confidence interval for this temperature of coffee. So we want to come out like this. We'll do this out, and then we'll do it on your calculator. So the first thing through is we got to find your margin of error. The only thing we're missing is your TC. So we know that 95% of your data sits here. This is 5, so this is 2.5%. We want this guy. They're going to be the same. They're symmetric. But all we want is the positive number. And that's exactly what your chart gives you, a positive number. So we notice we need degrees of freedom. What's your degrees of freedom? 15. This is important. So use your chart, come across the top to confidence interval 95, come down the degrees of freedom to 15, and find TC. It gives it to you in the positive. So what did you find for your TC? 2131. Okay, here's my negative side of it. Here's my positive side of it. All I need is the positive number. Unlike the z-table where we had the negative and we just used the positive, the t-score table gives you the positive number. It's same symmetry as your z-score, and you don't even have to worry about where it goes because it already does that for you. Now, let's plug this in. God bless you. The standard deviation was 10. The size of the sample is 16. Don't use your degrees of freedom here. Use your N. put it in your calculator exactly the way you read it. 2.131 times 10 divided by the square root of 16. You gotta make sure you get this formula right. So we're gonna round it because these were in 1 decimal. We're gonna round this to 1 decimal point. So what do you get? 5.3. Now, we set it up the same way. X bar, 162.0 plus or minus 5.3. So you take 162 minus 5.3, and you get 156.7, and you add 5.3, 167.3. Did I do it right? Okay. This is what I'm looking for. Also, if you wrote it the other way, you could write it out this way. 156.7 less than the mean, less than the 167.3. This kind of helps you say how to interpret this. I want to be 95% confident that my population mean will fall between, for my, oops, I got the wrong decimal place here. My population mean for my temperature of coffee will fall between 156.7 degrees and 167.3 degrees. That's where I'm hoping my population falls. I want to be 95% confident that my population will. I only did a sample of 16, and I took track of their temperatures of coffee. You feeling this a little bit? Okay, so you're going to try it yourself too on the top of the next page. You're going to create a 90 and a 95, a 90 and a 99% confidence interval for this. What's going to change? I'm sorry? The confidence is changing. So what's going to change in our formula? TC. TC is going to be where you're changing. Everything else is going to be the same. You want a confidence interval of 90. You want a confidence interval of 99. Now, if you put this on your calculator, yes, please? 297. If you put this on your calculator, guys, it's in stats, test, and come down, see where you see Z interval? Right underneath this is T interval. So I want T interval. I've got an interval, and I'm using my T-score.
So mean and stuff is going to do the same.
Everything is going to stay the same. 16, 162. You can put this in your calculator. N is 16. Make sure you put your N in and not your degrees of freedom because your calculator does that. Go put your confidence level in. Come down. And there is our 156.7 to 167.3. There's your confidence interval. Now this is nice to change. If the only thing that's changing is your confidence interval, you keep the same data and you change the 95 to 90. Then you change it to 99. If you can't work this formula, then learn how to use the calculator. Intervals are the easiest ones on the calculator. I think it just makes sense. It's got the word interval out there. A ZC for Z, a TC for T. It kind of makes sense. So you're gonna, can we do this part, guys? All right. So if you use your formula, this is what's changing. If you use your calculator, it's nice. Just go put in 90, go put in 99. So you should find your 90 to be 157.6. Is that right? To where?
166.4.
And how about the next one?
154 plus 6. 169.
Thank you. Okay, so watch. You guys need to remember this. As your confidence increases, we went from a 90, this guy, to a 95, this one, to a 99, this one. What happened to your confidence interval? it widens. Good. As your confidence increases, it widens. Now, if in a minute when we go try against the ZC, you're going to see that it's slightly larger. Because you do the n-1, you take up a little bit more slack here, so you give yourself a little bit more wiggle room in this. So as you go up in confidence level, your interval will widen. Okay? And it's always good to try, you can try this on your calculator. Your calculator is a great tool for this. Questions? No? Okay. That was a messy one, sorry. Okay. Let's try another one. All right. Number 3. You randomly select 20 mortgage institutions. There's your N. And you determine the current interest rate. The sample mean.
X bar.
X bar. Leave it as a percent.
SX.
With the sample standard deviation. Find a 99% confidence interval. So when you do the N, what's your degrees of freedom? 19. Do that right away. Because now, when you go for your margin of error, we need to find our X bar plus or minus 8. When you go for your margin of error, you need to find your TC. So go look at your chart where your degrees of freedom are 19 and your confidence interval is 99. So you're going to pull that out, and what's your TC? Can everybody find this off your chart? I find this chart is far easier to understand than your Z-score. You don't have to subtract anything. You do if you do your calculator, but not if you do your chart. That's why I find the chart is just easier. Standard deviation, 0.42, leave it the way you read it. N is 20, not 19. So we found our margin of error, and what should we round this to? How many decimal places? 2, because your mean is 2 decimal places. And we're keeping it as a percent. So we get 0.27. And then we just build your confidence interval. X bar plus or minus 0.27. We subtract 0.27 and we add 0.27. Here's your interval. I don't care if you write it that way or you write it this way. I think this way makes you kind of understand why we do this. You want to be 99% confident that your population mortgage interest rate will fall between these two numbers. Not your sample one, you know your sample one. So you're inferring about your population based on what you found in your sample. Again, the n-1 takes up a little bit of wiggle room in here, gives us a little extra by doing your t-score, because 20 is really not a lot to choose from, but maybe that's what we can find. Mortgage institutions, maybe there's not a lot around that you can sample. Okay, I think you pack it up. So Monday we'll finish this up. Probably looking at tests that Wednesday.
Second quarter.